Hello everyone. As part of learning generative AI, let us learn some of the concepts about multimodal deep learning. What exactly is multimodal deep learning? We can think of this word is coming from multi-mode. So what is multi-mode here? Various types of data is considered when you are working with the deep learning model. So let us talk about what is multimodal deep learning, what is the specific application we are going to see under this category. So multimodal deep learning, it refers to uh, integrating various parts of the various types of the data coming from varied sources, and you are trying to train the model using that different types of data. What types of data can we consider? The data can be a text information, it can be audio, it can be video, various types, it can be an image likewise. So you are trying to train the model by integrating the data coming from various types of resources who are providing or which are providing various types of data. And then you are trying to understand the data, the patterns on the data, and you are trying to generate responses from the model, right? So these models combine the data from diverse modalities. Diverse modalities means you are trying to take data from the sources which can generate various types of data. Why are we considering various types of data? Just to improve the performance, and you are not leaving any kind of information which will improve the accuracy and the relevance to the particular response from the model. For example, a multimodal deep learning model can analyze both visual information as well as textual information, wherein you are trying to have more promising interpretation of the data, such as understanding the image and describing it using natural language. What are the applications that are involved here? Maybe we can think of autonomous vehicle driving, medical diagnostics, sentiment analysis across various social networking websites, etc. Then the application that we will be considering under multimodal deep learning model is image captioning. What is image captioning? We are pretty much aware of this application. You are given an image, you are supposed to generate a caption for that, right? So what are the two types of data that are involved here? The image as well as the caption for that. Image is a pictorial information which consists of pixels and all. Caption is a textual information. So the visual data plus the text data, there are two types of data in this. You are going to understand the image and generate a caption for that. So because it is dealing with two types of data, it can come under the category of multimodal deep learning model. Why do I talk about deep learning? Let us see. Whenever you are trying to work with such type of image captioning example, first we need to understand the image. That means extract its features which are appropriate for generating the caption. Because you are trying to extract features from an image, what type of convolutional neural networks, what type of deep learning networks will be using? We are going to use CNN, convolutional neural networks. Once we extract the features, we understand the image features, then you need to generate a caption. Generating a caption deals with natural language generation domain, under which you are going to work with the RNN, which can understand the image features and generate the relevant text to give the caption. The goal for this system is to understand the visual content and translate the visual content into a text information. That is nothing but the caption. Image captioning applications, one big application for this stated is accessibility. What do I mean by accessibility application? For visually impaired people, it helps. They cannot see the image or they cannot see it with full clarity if at all they have partial vision problems. For such people, we are helping it with the caption. Then what is multimodal deep learning, right? Multimodal deep learning refers to integrating data from various types of resources and various types of data. And why are we dealing with various types of data? The only consideration here is to improve the performance. What is the key idea of combining the data from various types of resources and different domains? Because it helps us to understand and reason the capabilities of single model models. What are the key components of that? First of all, you need to have the primary components of multimodal deep learning model include what are the types of the data. So, first we will be talking about visual data. Visual data includes the images, videos, etc., which are processed by the CNN, or sometimes we might use the vision transformers. The other one, textual data. How are we going to generate the caption for an image, or how are we going to process the features of the image and generate it? For that we are using RNN or LSTM transformer based models likewise. Then how do I work with audio, speech, sound or other acoustic data? Typically processed using models like WaveNet, CNN or RNN architecture. Sensor data, when the data is coming from various IoT devices and sensors, then we are going to have that data under the data set. So, now what types of data are we considering? Text data, which is the caption, then images, then videos, audio, sensor data. Various types of data, multimodal deep learning. Why do I say deep learning? Because we are working with neural networks, CNN and RNN, we say multimodal deep learning model. Fusion mechanisms, what do I mean by fusion here? Fusion is like mixing or combining something. What exactly are we doing the fusion with, right? We are going to combine the data from various types, right? Some audio information, some video information, some sensor information, you are going to put it in a single space. This is called as fusion. So, how do I go for the fusion? The key challenge in multimodal deep learning is how to effectively combine data from different modalities. There are three types of fusion. Early fusion. What do I mean by early fusion? During the input phase itself, you are going to combine the data from multi-modalities. On the other hand, the second one is late fusion. What do I mean by late fusion? This is little bit interesting for us. First we process the audio information. Say for example, I got some audio input. First I process that, take its response. Then I send the text information to the model, take the response and keep it. Then I send the video information, take the response from the model, keep it. Then I try to combine these outputs whenever I fed various types of data to the model. This is called as late fusion, right? At the time of input only you are mixing all types of data, early fusion. You are trying to feed individual type of data to the model, take the response and then you are trying to combine those, you call it as late fusion. Hybrid fusion, it is a mix of both, right? Multimodal representations, how are we going to have learning shared representations of data from different modalities, right? What are we trying to do? For example, in multimodal learning for image and text, both the image and text are projected into a shared space, right? So, this is called as multimodal representations. Where are you going to hold this data for the model to learn? If at all we are going for early fusion or late fusion also, you need to have a shared space wherein the entire data from different modalities is kept there, right? What are various possible applications under healthcare wherein you are trying to capture the X-ray features and textual data from the patient records, which will help in better diagnosis. Autonomous vehicles using the visual data, that is the camera images and sensor data from the lidars and sometimes you use the textual information. What kind of textual information? Maybe the message from maps or road signs, in order to decide how do I drive the vehicle. How do I, in the sense, how does the vehicle automatically goes with the driving mode. Social media, we try to, this is the best example for multimodality data. So, social networking data is taken and you are trying to understand the sentiment and behavior. Robotics, you are trying to integrate the vision, audio and the tactile data in order to understand and give more human-like behavior to the robots. Image captioning. Image captioning is the task which comes under natural language generation. What it will try to do is, it will try to generate a caption which better describes the image. So, this image captioning application is combining both computer vision as well as natural language processing. Where is it using computer vision? When it is trying to understand the image. Where is it using natural language processing? When it is trying to generate a caption for the understood features of the image. What are the steps involved in image captioning? First, you need to extract the features from the image. Unless we understand the features of the image, we cannot generate the caption. So, the first step is to extract the features from the images, for which we will be using the CNN. The output of the CNN is a feature vector which shows all the features, important features of the image. Then once the image is processed, we are going for the text generation. In order to generate the text, what are we trying to use is, we are trying to use RNN or transformer based models. Using these models, what are we trying to do? The image features are taken as the input. Where are we having these image features? Which are generated as output from the RNN. So, you are taking those features as input and sequentially generating the words which will form a coherent and a relevant caption. Sometimes we might use the attention mechanism also in order to understand the importance of the words while generating the caption. Attention mechanism, whenever I say we are using the attention mechanism, it uses the model to selectively focus on different parts of the image, which will help in giving a caption with more relevant words than simply concentrating on something just belongs to the model, just belongs to the image, which may not be relevant in the context, right? Then this helps in producing more accurate and contextually relevant captions. Caption generation, once the model is understood the features, what it is trying to do is, it is trying to generate the caption by starting with one token at a time. Say for example, it has generated the initial token as a cat sat on the mat. Say for example, this is the caption I have to generate. The first token is a. Once it has generated a, then it is sequentially predicting the next word based on what is the current state, what are the previously generated words, and what are the image features. So, all these are trying to predict the next token. It continues the process until the end token is generated. Sometimes we might use beam search or greedy search in order to identify the best sequence of the words. Training. Image captioning models are typically trained on large data sets. Generally, we use MS COCO, Microsoft Common Objects in context. It contains more than 3 lakh images, wherein for every image approximately 5 captions are there. So, such a huge data set on which the model is trained, and during the training phase, the model will try to minimize the loss by using either cross entropy loss functions, which will try to help it not to have too much of error. What are the challenges in image captioning? You need to understand the context. We need to see the ambiguities of the language. Then we need to see the biases of the data. Whenever you are trying to generate a caption for the image, definitely it is subjected to biases. So these are the challenges involved in generating caption for the images. Then what are the applications of image captioning? Accessibility, as I told, this helps in making the visually impaired people to understand a particular image without seeing the image. They go through the caption and try to understand. Content management on social networking sites, etc., wherein auto tagging feature, right? Then medical imaging, reading the x-rays, patient records, which will help to understand the diagnosis and the treatment plan. Search and retrieval, improving the image search. These days we are trying to search on Google using the images, audios likewise. So what is the connection between multimodal deep learning and image captioning? So this will how is the application of image captioning fitting into multimodal deep learning? As I already mentioned, under image captioning application we have two types of data. Whenever we are dealing with more than one type of data, it fits into this category. So in the next session we will be talking about multimodal deep learning and the data set which is helping for training.